I think I finished all my rabbit holes. So let's continue here. Let's go back to the audio amplifier out of experimental methods. There was something else I wanted to show you on LTSpice here. Now we ran the simulation where we swept the audio amplifier from 200 hertz to 20 kilohertz. And that works if you have a working amplifier. Now sometimes you will build something, this is simple, and it doesn't quite work. Well, there's something else that we can use to analyze the circuit, and that is, I want to look at the DC voltage at each node. In order to do that, I need to go over here and do a edit simulation command. And then there is a tab down here on the far right that says DC operation point. Click on it. It says compute the DC operating point, treating capacitances as open circuits, because all they'll do is charge up to a certain voltage, and inductances as short circuits. That's assuming they're quality inductors. And this thing brings up the .op command, but it has some parameters at the end, and we don't need those. You can leave them, but they're kind of confusing, so let me take them out, and let's do an OK. And now we put the .op command, let's put it down here next to the AC command, just comment it out. Now we go and do simulate. We'll run this, and we get this window pop open that shows all of these nodes and their values. Now, since I don't know where the nodes are, actually I do. I think this is number 1, and this one, where we put the sine generator, this is number 6. But let's just kill this window. Now I want to go to a point. Let's see here. I want to measure. Where's my... I think I just go there and click. Yes. And that shows me that at R1, R2, and the base of Q1, the voltage is 2.197. Same calculates it to 8 places, but you're never going to get those values. Just take the first 3 and go on. So we look at this node here between R3 and R4. And it's 1.33. The collector of Q1 is 6.16 or 6.17 if you round it up. The base of Q2 is 6.8. The collector of Q2 is 7.71, 7.718, 7.72. The collector of Q3 is tied directly to the 12 volts, so I expect it to be 12 volts, and it is. The point between R7 and R8 is 6.94. Now, if I want to look at the emitter of Q4, click there, and it doesn't know what it is because it's not for some reason it doesn't assign it a node. Same way here. For this emitter, I get a question mark. Let me go and run it again. That these values doesn't change. But I figured out something. If I go and take a wire and add a wire at this node, and just end it, now, since it created a node, it's got a voltage, 6.84. Same way at this other point. I'll just add a node, well, add a conductor well, if I remember how to do it. Now, it says that the voltage there is 34.08. I don't believe that. Quit. Sorry, playing around here. So let's rerun the simulation. There we got a 6.855, which I can believe. So even though LTSpice has been used for decades now, there's still some little gotchas here and there. So I just want to take this moment, or this episode, to show you how to calculate the DC voltages. And what you can do is you can power up your amp, don't feed it any input, and then you can take your little digital multimeter and measure all these points and see if that's what you get. And lots of times you can find a wiring error. So that's it. Wanted to show you that. We're going to go on and start another project. I'll be back shortly.